Hello, in today's daily Leetcode challenge, we are going to solve this question palindrome partitioning. So, in this question, we are given a string. We have to partition S in such a way that all the substring of the partition is a palindrome. Return all possible palindrome partitioning of S. Right. So, if we look into the example number one, what we can see that if we partition this string from this two in between spaces, so it will become AAB, and that's a palindrome in them itself, right? And if we partition this string from here, so AA is a palindrome and B is a palindrome, right? I hope you got the intuition that for every index we have to find whether the remaining substring have a partition or doesn't have a partition and is a palindrome or not, right? So I think for every index we have to check whether starting from that index how many palindrome could be possible and where we are doing that partition, right? So we can do this question via backtracking, and at every step we will calculate the substring which are palindrome in nature in the process of partitioning, right? So let's move ahead and look into the example. Initially, if we get a substring or a string of AAB, so all the partitioning which are possible in this AAB is AA and AB, right? If we partition at the first, after the first index it will become A, after the second index it will become AA, after the third index it will become AAB, right? And if we look closely, this A is a palindrome and this could be our possible answer. So in this first partitioning we have A is as our answer, right? If we move forward, so this A is processed, right? And we have to partition the following and the rest of the string, right? So if we partition at the first index it will become AA, and similarly it will become if we partition after B it will become B, right? So all of the substring which are palindrome in nature, and if we start partitioning after the index number one, we got along the edges of the tree, right? A A B are a palindrome, this AAB are a palindrome, right? So I hope you got the approach that at every index we have to partition rest of the substring and check whether the remaining substring create a palindrome or not, right? So let's start coding this question. Also, looking at the constant of the string length can go up to 16. So whatever we do in the backtracking, it could not affect our time complexity because the length of the string is minimum as possible. So let's see how we can solve this question. So what I have done here is that I have started with index number 0, and for every index I start partitioning the array according to the next indices and including the next indices. If the next index including the next index, like if the array at that point is a palindrome, right? If I am starting from 0th index and I have at 0 index, if it is a palindrome, so it will be in our my current answer, and it will be an answer for the current partitioning process, right? So after I partition all the string up to the size of the string, I will add them into the final answer, right? So this is the solution for this question. Let's try to submit this question. I have run this and check for the compilation errors. So let's try to submit this. Right, so it got accepted in C++. Let's try to do this question in Java. So I have run this Java program, and also I have corrected all the compilation errors. So let's try to submit this. So it got accepted in Java as well. So this is the solution for today's daily lead code challenge, palindrome partitioning. Thank you for watching.